Today's video tackles a common problem that many developers run into when optimizing their code. The problem we are discussing involves understanding the x86-64 assembly code generated by Clang with the O2 optimization flag for a specific function. The assembly code seems complex with loops and constants, making it difficult to decipher the optimization techniques used by the compiler. Now, let's delve into the solution that was provided for this problem. The solution involves identifying a regression in Clang 19, where the auto-vectorization behavior changed from previous versions. The newer versions of Clang utilize assigned to float conversions for SIMD vectorization, resulting in a different optimized code structure. This unintentional change in behavior results in suboptimal vectorization and can impact the performance of the code. To summarize, understanding the intricacies of compiler optimization and vectorization techniques is crucial for maximizing code performance. By being aware of potential regressions and unexpected changes in compiler behavior, developers can write more efficient code and avoid performance pitfalls. I hope you found this explanation helpful. Remember to subscribe, like, and comment below with any questions or feedback. Thank you for watching.